to send you a link to one again.
I have my unit
You
circle.
have one here. Perfect. All right. Okay, so last time we did some pretty basic problems. We said things like, when is the sine of x equal to negative square root of 3 over 2? Okay, and this is always the basis of types of problems that we're going to solve here. So for this, something like this here, there's two places on your unit circle where the y value is minus root 3 over 2. It's here, and here. Okay, can you give me those values on the unit circle?
It's 5 pi over 3.
Okay, it sounds like this one over here.
And 4 pi over 3.
This sounds like this one over here. Okay, good. So those are the best. Those are the ones where it's like, yeah, everything's in good. We've got everything kind of down. And then they get more difficult from here. So, so one of the ones that you will see is, let's see here. I don't want to do this. Something like cosine squared x equals 1/4. Second. Equals, no, sorry, equals, why is this not making sense here? All right, give me just a moment here to find some problems. That's what I've meant to do. Okay, so here's one, equals 3 over 4. Okay, this is what I was looking for. So this one's not as explicit. Like you have to do some things to get this solved for cosine of x in this case, and that is you want to take the square root of both sides of the equation. Now, as a reminder, gentle reminder here, it's plus or minus the square root of 3 over 4. Okay, and so on the left here, it's cosine x equals plus or minus, you take the square root of the top, square root of the bottom, and this nicely reduces to the square root of 3 over 2. Okay, so now it's really two problems. It's really, where's the cosine of x equal to root 3 over 2? Where's the cosine of x equal to the negative root 3 over 2? And the answers, you combine the answers, but it's really like a problem on the left and a problem on the right. So could you tell me these answers here? Again, it's on the unit circle. You're looking for now where the x value is root 3 over 2, and then negative root 3 over 2. There should be four values altogether.
Okay. 7 pi over 6 is where it's negative 3, root 3 over 2.
Okay.
So is 5 pi over 6.
Okay.
And then pi over 6 is positive root 3 over 2. And then 11 pi over 6.
Yes. Now, in terms of like how you answer it, I mean, I'd love it if they were in ascending order, but I would take this as
Okay.
is. Okay. Now, how comfortable are you with this square root stuff?
I don't know.
Okay, well, let me give you one to try here. Sine squared x equals 1/2. Okay, I want you to take the square root of both sides and then rationalize. You do want to rationalize in this problem. So for me, what I'm looking for is to tell me what the right-hand side becomes after you take the square root and rationalize.
Um,
Question, something I can help with?
no.
Okay. Do you have an answer for me here?
No.
Okay, so you're gonna take the square root of the top and the square root of the bottom,
Yeah.
right? Do you know the square root of the top?
1.
How about the bottom?
No.
No. So you leave it. You're like, all right, I don't know that, so I'm gonna leave it, and that's fine. That's okay. That's where this rationalize comes in. Okay. Do you remember how to rationalize something like this?
No.
Okay, so you eliminate the root on the bottom. Rationalize basically means no roots on the bottom. So you multiply the top and bottom by √2. So in the numerator, it's √2. But in the denominator, it's √2 times √2, which is square root of 4, which equals √2 over 2. So what I'm trying to get you to what I was asking here, and this is the key here, is to be able to go from this first place in red all the way to this second place. And the nice thing is there's only a few of these that you have to know how to do, but you got to be really fluent in them. You got to be fast. Is that okay?
Yeah.
All right. So now it's really two problems. It's really sine x equals √2 over 2. Sine x equals minus √2 over 2. So this time, I really want you to start on the unit circle, go counterclockwise. Okay, and we're looking for where the y value is √2 over 2 or minus √2 over 2.
3 pi over 4.
Okay, that's this one over here on the left. 3 pi over 4.
5 pi over 4.
Okay, that's that one there.
7 pi over 4.
Okay,
And pi over 4.
okay. And we really want them in that nice, ascending order. Like this. And that is your final answer. Give me some feedback. What do you think you understand? What do you think is still really unclear in the problems we've done?
I don't know. I just know I know how to do the last steps. I just don't know how
Yes.
to do the beginning step.
Yeah, and you're doing great. You will build fluency just doing that. Man, that's huge. Okay, let's try. Let's just keep trying here. Let's say I give you something like this: 2 cosine x plus 1 equals 0. And I ask you to solve. Okay, solve for x. It'll say from 0 to 2 pi most of the time. We'll talk about those exceptions. Okay. So what I'm really asking you to do is to isolate the cosine of x.
Yeah.
Okay. So can you tell me what the cosine of x equals once you've isolated it?
It would be 1/2.
Close.
Oh,
This
minus 1/2.
minus
Yeah.
1/2. Okay. Yeah, minus 1/2. Okay. All right. So now can you tell me, because you just said it, this is the step you're really good at. Can you tell me where cosine of x is minus 1/2 on the unit circle?
2 pi over 3.
Okay, so somewhere here-ish. That's not quite right. I guess it's more like that. Yep. And then any other places?
4 pi over 3.
4 pi over 3. Good. So 2 pi over 3, 4 pi over 3. Okay, good. So you got those. Those aren't too bad. Now this is kind of off to the side here. If I ask you to solve x squared equals 1, can you tell me what the two solutions are?
Positive and negative 1.
Yes. Now to get them, you took the square root of both sides.
Yeah.
And then maybe you just know the answers, but that's what you're doing when you did. So if I give you a problem like this, if I say tangent squared x equals 1, how do you isolate tangent of x? How do you get tangent of x to be by itself?
Square root.
Square root both sides. So square root tangent squared x equals plus or minus 1. So tangent x equals plus or minus
1.
1. Okay. Now this really turns into two problems. It's tangent of x equals 1. Tangent of x equals minus 1. Okay, now before we try to answer this, we're gonna do a little sideways tangent here. And we're gonna look at the first quadrant of the unit circle together. Okay, so let me snip that in here. Okay, so here's the first quadrant of the unit circle, the values that we care about. So can you remind me, what is tangent of x in terms of sine and cosine?
It is sine over cosine.
I couldn't help but hear maybe you flipping the page on something. I think that's fantastic that you got it out and in front of you. So that will definitely help here. Even better if you can get your teacher to let you use it on the test.
Hopefully.
So you ask, make a deal. All right, now in terms of x and y, this is really y over x. Okay. So we're gonna do this for 3 problems. We're gonna look at pi over 6 first. So pi over 6, what is the y value?
1/2.
Okay, and what is the x value?
Square root of 3 over 2.
Okay, so you have to be, there's a couple of things you have to recognize. One is you have to recognize this right here, this 1/2 over root 3 over 2, but that's not how it's going to be presented to you. But we'll come back to that in a moment. Now, in terms of this, you never divide, you always multiply by the reciprocal. So this is really 1/2 times 2 over root 3.
Yeah.
Okay, and this becomes 1 over root 3. Is that okay for now?
Wouldn't it be the 2 in front of the root 3?
So let's back up here, talk about so another approach here, I'll just give you another way of thinking of this, maybe this is better, is you multiply the top and bottom by the reciprocal.
Mm.
Now on the bottom, let's just multiply it out. Yeah, it's 2 times root 3, like you just said, 2 times root 3. But what happens there? Do they?
Oh, they cancel out.
They cancel. And on the top here, it's 2 over 2 root 3. So the 2's cancel.
Oh, okay.
Okay. So this is what's confusing for students. And I appreciate you actually letting me work through this with you, because you're going to fully understand this now. The tangent of pi over 6 is everything in green. It's 1/2 over the square root of 3 over 2. It's 1 over root 3. And then finally, if we rationalize this, we multiply the top and bottom by root 3. It becomes root 3 over 3. Okay, so I'll summarize here, but you as the math student, like, it's not like sine and cosine. You have to be on the lookout for the fact that tangent of pi over 6 can be 1/2 over square root of 3 over 2, or it can be 1 over square root of 3, or it can be root 3 over 3.
Okay.
Okay, now, if you want to know why, we'll get to that, we'll do a subsequent problem, but we're going to do the same thing now for tangent of pi over 4. What's the y value at pi over 4?
Root 2 over 2.
Okay, and how about the x value?
Root 2 over 2.
Okay, what does this reduce to?
1.
1. All right, now let's do the other one. Let's do tangent of pi over 3. So it's essentially the flip of the one we just did. It becomes root 3 over 2 over 1/2. And then this time, if you multiply the top and bottom by the reciprocal, the bottom cancels. So you get, this becomes 2 over 2, and then 2 root 3 over 2. So the 2's cancel, and root 3 over 1, like that. So this becomes just root 3. Now again, if you're wondering, like, why are we doing this? It's because you're going to get a problem that looks like one of these forms: 1 over root 3, root 3 over 3, 1, root 3. But you have to map it back to the y over the x. So let me try to explain that, going back to the previous problem here. So we did work this problem where tangent of x equals 1. Now, while you may know that that's here on the unit circle, okay, what you have to also be able to tell me is that it's really root 2 over 2 over root 2 over 2. Because you just told me that this reduces to 1, right? Where they're the same. But it's also where it's minus root 2 over 2 over minus root 2 over 2. Is that okay?
Yeah.
And on the right, it's the one where it's root 2 over 2 negative over positive root 2 over 2, or it's positive root 2 over 2 over negative root 2 over 2. And that's those 4 places here on the unit circle. Okay, so just to summarize here a little bit here, because I know this is a lot here. Tangent of x can take on the following values. It can be 0. All right. It can be the square root of 3. It can be the square root of 3 over 3. It can be 1. Okay, but it can also take on these like deceptive forms, which is that 1 over, or I'm sorry, that the square root of 3, what did I say here? Sorry, the square root of 3 over 3, this one right here, can also be 1 over the square root of 3.
Right.
All right, and then the square root of 3, that one's not as bad, but it can kind of take on a few. You have to reckon. So this one is this other form here, but in terms of like the y and the x, like this is where you got to know your y over x relationship. Like the 0 is really 0 over 1. The 1 down here at the end, these are the easy ones, is the root 2 over 2 over root 2 over 2. The square root of 3 is the square root of 3 over 2 over the 1/2. The root 3 over 3, or the 1 over root 3, is the 1/2 over root 3 over 2. Okay, I know this is a lot. This is all like stuff that you were supposed to know. I'm not gonna, I mean, that's just the way it is, but this, I hope, gives some clarity to what we're doing.
Yeah.
All right. Now, not to make it worse, but it's plus or minus, plus or minus, plus or minus. Meaning like it could also be the case that it's, if this one was negative, like one of these are negative, the other one's negative. That's where this really gets hard. That's where it's like, So let's do a problem. Let's do a problem here so you can see this. Let me know if you've got all this down.
Got it.
Okay. So this knowledge is all to help you be able to answer a problem like this. What is the tangent squared x of, what is tangent squared x equals 3? And it says to solve for x. Okay, so to solve for x, you take a square root of both sides.
Right.
Plus or minus the square root of 3. So it's 2 problems now. It's tangent x equals square root of 3, tangent x equals minus square root of 3. But here's what you have to know as the student. You have to say, oh, this is really root 3 over 2 over 1/2. This is root 3 over 2 over 1/2. But it could be that the numerator is positive and the denominator is positive, or it could be that they're both negative. You follow that? See it like the two positives make the positive, the two negatives make the positive.
Yeah.
And then the one on the right here, one of them is negative. Maybe it's that one. And then the other one is positive. So let me get the color coding here. √3 over 2 over 1/2. And this tells you, knowing this information tells you where to look on the unit circle. So this first one in green, you're looking for where the y value is square root of 3 over 2 positive, and the x value is 1/2.
Pi over 3.
Pi over 3. Yes, this is pi over 3. Then you're looking for where they're both negative, but the y value is minus √3 over 2. X value is minus 1/2.
4 pi over 3.
Okay, and then the next one here is where y value is negative, but the x is positive.
Um, 11 pi over 6.
That's
Oh.
the flip. Yeah,
5 pi over 6.
that's 5 pi over 3.
Oh,
Because
okay.
it's y over x. Y over x. Okay, how about the last one here? Positive y, positive square root of 3 over 2, negative 1/2.
11 pi over 6.
11 pi over 6 has got the flip of it. Let me grab that here. Just grabbing a snip here. So 11 pi over 6 is, this is the y is minus 1/2. The x is the √3 over 2. You're looking for the switch of that.
5 pi over 3.
You've already given me that one. So this one here is 2 pi over 3. 2 pi over 3. Let's just grab that in the unit circle again. Right here, and just show that to you. Here we go. So again, that's the y value is the positive one up here, and then the negative 1/2 is the x value, like this.
Okay.
All right. So let's do, kind of the other style of problem you'd see here, which is tangent squared x equals 1/3. So just like in the last problem, we have to take the square root of both sides. Square root of tangent squared x plus or minus square root of 1/3. This one though, on the right, you have to work out. It's square root of 1 over square root of 3. So square root of 1 is 1, square root of 3 is 3. Okay, so you have a choice. You have a choice here. Like, you either know that what this is really mapped to this one right here, or you rationalize, that the rationalized one is mapped to this one right here. And the reason we're doing this in red is because it's the y over the x. It's the sine over the cosine. You can't do it without knowing these numbers. Okay, so like what I want you to do is be able to see that this is √3/2 and then 1/2 here. And we just worked out that this simplifies to the one on the left here. Because that's easier. That's easier to look up. That's the sine value. That's the cosine value. And maybe that's more helpful for you. Like, so here's what I'm trying to say is that you're looking for sine being 1/2, cosine being √3/2. So you're looking for this on the unit circle. That's plus plus. Then you're also looking for where they're both negative. Maybe that's easier to see. I don't know. And then you're looking for where one of them is positive and one of them is negative. So positive, negative, negative, positive. Would this be easier than trying to figure out where, kind of looking at the numerator denominator?
Yeah.
Okay, so I'm gonna recommend we do this now for future problems. It will really help you to figure out where this place is on the unit circle. Let me know when you got some of these values.
Oh, sorry.
I already know where all of them are, so it doesn't help me to just write them down. But I want you because
Yeah. Pi/3.
good.
4pi/3.
I messed this up. I'm sorry.
It's
I have
okay.
these all switched because these are the same answers that we got in the last one. All right, so that's so it's √3/2, 1/2. Yeah, it's y over x, and then both negative. Okay, and then one's positive and one's negative, and then the other's negative, and then the other's positive. Okay, this will do better. It should.
Okay. Pi/6. 7pi/6. 11pi/6. And 5pi/6.
What do you notice about the denominators of all these?
They're all 6.
And how about in the last problem? What did you notice about the denominators of all these?
They're all 3.
So that does hold true for some problems where you're just dealing with one trig function. There is kind of a pattern to it. That's one of those things where I mentioned, like you can use the unit circle to answer some of these things. When we did problems like cosine, there's kind of a pattern there. They both have 3. The sine also both kind of had a pattern of all being on 4s. That's kind of stuff should help stand out. It also helps you to reduce your how much these all had 6 in them. It helps you don't have to necessarily write out all the points like I did. You just have to start looking for where they are on the unit circle. All right, let's try another one here. Let's say, just keep it kind of simple here. Let's ask, I want you to try solving this one. Solve cosine squared x equals 1. If you have questions, please ask, but this one is very similar to the ones we've been doing. But a little bit easier, less values.
So if I did this right,
Okay, tell me what you did first.
I square rooted both sides.
Okay, so what does cosine x equal?
1
Anything else?
and -1.
Okay. What is your answer for this?
So I got 2 pi.
So it goes from 0 to 2 pi where it excludes, that one's excluded, but the
Okay.
0 is included. So you would just switch your answer to 0. Good,
Okay. 0 and pi.
good. Okay, very good. Let's try another one here. Let's go, let me just look back and see which ones we've done. Trying to not make them too big a deal here. All right, so 4 sine squared x minus 3 equals 0. Okay, so this one is another solve for x. Okay, and I would recommend isolating the sine squared first.
Okay. Okay.
What does sine squared x equal?
I got square root of 3. Oh no. Oh my god.
Maybe you're giving me sine x. That's what I want
Yeah.
that too. Okay, what does that equal?
Sin x.
Yes. What goes on the right side here? Right
Oh,
side
square
equals.
root of 3/4.
Okay, and what does that reduce to?
Um. I don't know.
Okay, so you have to take the square root of the top and the square root of the bottom.
Oh, square root of 3/2.
Plus or minus, right?
Mm-hmm.
So there's really two here that you're looking for.
Pi/6 and 11 pi/6.
That's only half the answer. What I mean by two is there's two equations here. There's the positive one
Mm-hmm.
and the negative one.
then it's 5 pi over 6 and 7 pi over 6.
Yeah,
And
so
then
it's all, it's a lot of pi over sixes, right? It's, actually, let me check that here. That's the y value. Sine is the y value. So go ahead and check your answer for me.
oh, yeah. 2 pi over 3.
Anything before that?
Probably.
Yeah, probably, since I'm asking.
Pi over 3.
Okay, good.
And then there's 4 pi over 3
Okay,
and 5 pi over 3.
all right, good. All right, yeah, so let's do another one here. Let's go, let's see. Cosine. What have we done here? Let's go. 4 cosine squared x minus 2 equals 0. So try solving this for x, please.
Mm.
Did you get it down to cosine squared x equals 1/2?
Yeah.
Okay, so the next kind of like obstacle milestone here is to get the right roots here.
Yeah. Is it one of them 2 pi over 3?
Okay, what give me this part here. What is it? What is the cos? There's 2 cosine x equations. What's the one on the left and one on the right? Or
One's negative square root 1/2.
okay, but what is that? That's so the square root of 1/2 is not on your unit circle. Is but the reduced of this one is. So like just like in the last problem where you said, yeah, it's the square root of 3 or 4. It's like you're right, absolutely right. But you have to do this on the right here. You have to rationalize.
But you
You have
can't
to,
reduce it.
well, this one becomes root 1 over root 2,
Yeah.
but now you can rationalize it. You multiply the top and bottom by root 2. Can you tell me what that becomes?
um root 2 over 2.
Root 2 over 2. Good. So that's what I was looking for here. Is it's like, hey, it's negative root 2 over 2, and it's positive root 2 over 2.
What?
So can you find these places on the unit circle?
Oh yeah. 5 pi over 4. Well, 3 pi over 4 before that.
Okay.
7 pi over 4 and pi over 4.
Okay, very good. All right, I'm gonna just stop recording here.